Hi students, let us see next sorting technique, insertion sort algorithm. This insertion sort algorithm is a simple algorithm, okay. It takes elements one by one from the unsorted list and insert that elements in their correct position in the sorted list, okay. This insertion sort algorithm works by taking elements from the list one by one and inserting them in their correct position into a new sorted list. So it takes elements from the list one by one and inserting that elements in their correct position into a new sorted list. Okay. So this insertion sort algorithm takes the elements from the unsorted list one by one and insert that elements at its correct position in the sorted list. Okay. So let us see the pseudocode. If it is the first element, it is already sorted. See here, this is the unsorted array. In this array, if it is first element, it is already sorted. Okay. Let us assume this first element is a sorted element. Okay. So these are unsorted elements. So if it is first element, then it is already sorted. Okay. So this element is sorted because this is first element. Okay. So it is already sorted. In second point, pick the next element. Okay. Pick the next element. So take the next element. Okay. Which element? 2. This is the next element. Compare with all elements in the sorted sublist. Compare with all elements in the sorted sublist. So this element is sorted. These elements are not sorted. Okay, unsorted elements. So compare this second element with all elements in this sorted sublist. Sorted sublist means what? This number. Okay. So compare these two elements. Okay. So which one is greater? This 5. Which one is smaller? 2. So you have to insert this 2 here in the sorted list. Okay. Because 5 is greater than 2. So you have to insert this 2 here. Okay. See the next point. Shift all the elements at its correct position in the sorted sublist. Okay. First take the elements from the unsorted sublist and compare that element with the sorted elements and place that element its correct position in the sorted sublist. Okay. Insert next element 2, 5. These are the sorted list. Okay. Next write the unsorted elements 3, 8, 9. Okay. Next take the next element 3. Okay. You have to insert this element in the sorted list here. Okay. Next take next element and insert that element in the sorted array at its correct position. So repeat the same procedure until all the elements in a list is sorted. Okay. So let us see one example. Then you clearly understand about the insertion sort algorithm. Take some elements. These are unsorted elements. You have to arrange these elements in ascending order, which means in sorting order using insertion sort algorithm. So let us see that. Okay. So in insertion sort algorithm, you have to insert the element one by one. Okay. Now let us assume the first element is 44. Okay. So this first element is now sorted. Okay. Let us assume this 44 is a sorted list of item. Okay. So next write the remaining elements. So now we inserted the element 44. Okay. At first we inserted the element 44. Okay. So this is the pass 1, which means this is the iteration 1. Okay. So let us assume this red colored elements are sorted subarray and this green colored elements are unsorted subarray. Okay. So this is sorted, this is unsorted. So after pass 1, you have to insert the second element. What is the second element? 16. So insert 16. Okay. Compare this 44 and 16. Which one is greater? 44 is greater. This is the smallest value. So you have to write this 16 here and shift this element here. Okay. So now these are the sorted elements and the remaining elements are unsorted. Okay. This is the pass 2. After pass 2, insert next element 83. Okay, next element, insert 83. So compare these three values. Which one is higher? This is smaller. Okay, so write 16, 44 and 83. Next write the remaining elements. So this is the pass 3. So after pass 3, insert next element. What? 7. Insert this element. Okay. So compare which one is smaller. 7. Okay. 7 here. And shift other elements. Here 16. Here 44. Here 83. So write the remaining elements. Okay. So this is the pass 4. Okay. After pass 4, insert the next element. Okay, 67. Insert 67. So this is the 67. Okay, the 67 is greater than 44 and smaller than 83. So this will come here. Okay, so we have to write 7, 16, 44 and next this 67 and 83. Okay, next write the remaining elements. Okay, so this is the pass 5. So after pass 5, insert next element. Insert next element is what? 21. So 21 is insert 21. So compare this 21 with the sorted elements. 21 is greater than the 16 and smaller than 44. Okay, so you have to insert this 21 between these two elements. Okay, so write 7, 16, next 21, next 44, 67, 83. Next write the remaining elements. So this is the pass 6. So after pass 6, insert next element, that is 34. So compare this 34 with these elements. This 34 is greater than 21 and smaller than 44. So you have to insert here. Okay. So 7, 16, 21 and 34, 44, 67, 83. And write the remaining elements 45 and 10. So this is the pass 7. After this pass 7, insert next element. Which one is next element? 45. So compare this 45 with the sorted elements. This 45 is greater than 44. So you have to insert this 45 here. Okay. 7, 16, 21, 34, 44. Next this 45. Next 67, 83. Remaining element is 10. This is the 8th pass. Okay, after pass 8, insert next number. Insert 10. Okay, 10. So now you have to insert 10. So 10 is greater than 7 and smaller than 16. So you have to insert 10 between 7 and 16. Okay, so 7, 10 and next 16, 21, 34, 44, 45, 67, 83. So now you can see here all the elements are arranged in the sorting order. Finally we got the sorted array. Okay, see here, this algorithm uses n-1 number of passes to get the final sorted list. n-1 means what? N means number of total elements. Okay, total elements. Number of total elements is what? 9 elements. So n minus 1 means 9 minus 1 is equal to 8. Okay. So this algorithm uses n minus 1 number of passes to get the final sorted array. Final sorted array. Okay. So see here, number of elements 9. That is n. Okay. That is n. So n minus 1 means 9 minus 1, 8. So we have to complete n minus 1 number of passes to get the final sorted array. Okay. Here n minus 1 means 8. So you can see here after completing pass 8, we got the sorted array. Okay. N minus 1 passes, which means 8 passes. So after 8 passes, after 8 iterations, we got the final sorted array. Okay. So this is the way you have to do the insertion sort. Okay. So this is about insertion sort algorithm. This is very important question. So study well for your exam. Thank you.